Here we go, lesson 19, and I'm going to try to do lesson 20. 19.1, it's on page 133. Mentally evaluate all of the missing angles in each figure. So what I'm going to tell you is that a circle, a whole circle, has 360 degrees. A straight line is 180. If this is 50, this is 130. The 50 and the 130 in this case are known as linear pairs. Linear pairs are two angles forming a straight line. They both add up to 180. Let's go to B. If you know that concept, then you know this plus this will equal 180. Therefore, this is 150. Same goes here. 150 plus this will equal 180. So this is 30. This plus this will equal 180. So this is 150, which leads us to the next phenomenon. Vertical angles are congruent. Examples of vertical angles, the two 30s and the two 150s. How do I always remember vertical angles? This to me looks like a V. This to me looks like an A. 1 is congruent to 2. 3 is congruent to 4. So 1 congruent to 2. 3 congruent to 4. 1 and 2, vertical angles. 3 and 4, vertical angles. Figure C. This is 65. The whole thing is 180. Therefore, this is 115. Now, you now know that vertical angles are congruent. So 135, this is also 135. Now we're going to go back to this concept, linear pairs. This plus this have to equal 180. So this could be rewritten as 180 minus 135. $45, $45. So you use the linear pairs concept to also prove vertical angles are congruent. And we're going to talk about that more. 19.2. That can't be right, can it? Here's a figure where ray R meets line L. The dashed rays, that and that, are angle bisectors. An angle bisector cuts an angle in half, and it creates two equal angles. So that's going to be the same as that. That's going to be the same as that. Diego made the conjecture. The angle formed between the angle bisectors angle bisector, angle bisector, is always a right angle no matter what the angle between R and L is. So no matter what the angle between R and L is, he's saying that the angle between the angle bisectors is always a right angle. Label the diagram and rephrase Diego's conjecture more precisely using labels. So if this is an angle bisector, then this and this are the same. Let's just call them X and X. If this is an angle bisector of this obtuse angle, then these two are the same. So let's call these two Y. What Diego is essentially saying is that no matter where R is, X plus Y will always equal 90 degrees. In other words, a right angle. Number 2, is the conjecture true? Explain your reasoning. For this, I'm going to remind you that a straight line is 180 degrees. We got a Y plus a Y plus an X plus an X equaling 180. So Y plus X plus X equals 180. Y plus Y, 2Y. X plus X, 2X equals 180. Okay. Factor out a 2 because it's the same coefficient for both the Y and the X. So you just take out a 2. So 2 times, in parentheses, X plus Y equals 180. We're trying to prove that X plus Y equals 90, right? Just divide both sides by 2. So 2's cancel out. X plus Y equals 180 divided by 2. Or in other words, 90 degrees. 19.3, convince me. Here are 2, there's 1, 2 intersecting lines that create 2 pairs of vertical angles. There's your first pair, there's your second pair. What is the relationship between vertical angles? Well, I think vertical angles are congruent. For example, the ones are congruent and the 2's are congruent. How do you know? Let me show you a couple ways you could prove this. call that J, O, H, and let's call that center intersection point F. G, O, H, N, F. A couple ways you could do this. You could rotate angle OFH 180 degrees. OFH lands directly on NFJ. That's one way to do it. You could rotate the entire angle 180 degrees, and it'll always land there. It's even simpler way to understand it. Imagine we have ray FO, and we rotate that ray 180 degrees. It'll end on FN. What if we rotated FH 180 degrees? That'll end up on FJ. So FO 180 degree rotation becomes FN. FH 180 degree rotation becomes FJ. Because this ray ends up here with the 180 degree rotation, because this ray ends up here with a 180 degree rotation, we now know that this angle will be congruent to this angle. So how do you know? Rotate both rays of any of the angle 180 degrees, or rotate the entire angle 180 degrees. All right, let's do the cool down. Lesson 19, cool down. Give the most convincing explanation you can for why A equals C. This is A. This is C. Why does A equal C? A and B. A and B are linear pairs. B, and C are linear pairs. Line, 2 angles. Line, 2 angles. A plus B equals 180 degrees. This angle plus this, 180. C plus B equals 180. Why? Linear pairs. Let's try to isolate A. Just gotta subtract B to both sides. That cancels. A equals 180 minus B. Let's just subtract B to both sides. As long as you do it to both sides of the equation, you're good. These cancel out. C equals 180 minus B. Ho ho ho, 180 minus B, 180 minus B. If A equals 180 minus B, and C equals 180 minus B, A equals C. Let's move on to lesson 20. There's your cool down. It's a long one. Reminder, practice problems every lesson. You got to do them. If you don't, it goes in one ear and out the other. Lesson 20. Lines L and M are parallel. Mentally, forget mentally, we are evaluating the measure of X in each figure. So, see this angle right here? Doesn't it look an awfully lot like this angle? Let's use a protractor just for good measure. Just gotta put the vertex, the intersection point right there. Make sure this line and this line are parallel. X is 40 degrees. It's the same as this. This line right here is known as a transversal. They told us L and M are parallel. So we have a transversal cutting across two parallel lines, creating this angle and this angle. These two angles are known as corresponding angles. Corresponding angles are congruent. Let's take a look at this one. This one's 61. I wonder what this one is. Just put the center inside the protractor. get a measure on that. That line's parallel to that. 61. X is 61 degrees. Again, transversal line cutting across two parallel lines. This one and this one are congruent. These are known as alternate interior angles. Alternate interior angles are congruent. How do I remember that? Well, you've got a transversal cutting across two parallel lines. These two angles are on alternate sides of the transversal, and they're on the inside of the parallel lines. So alternate interior angles. Those are congruent. Let's go to C. Gotta find X. There's 81, 82. X is 82 degrees. What's 98 plus 82? 98 plus 82 is 180. This angle and this angle are known as complementary angles. Complementary angles are not congruent. That's the wrong way to describe them. Complementary angles add up to 180. 98 plus 82. That's a good example. Now, there's only one instance where complementary angles are congruent, and that's if they're both 90 degrees. All right, let's move on to figure D. Obtuse angle, obtuse angle. X is 125 degrees. These angles are known as alternate exterior angles. Alternate exterior angles. They're on alternate sides of the transversal. They're on the outsides, aka exterior, of the parallel lines. Alternate exterior angles. These are also congruent. They're the same angle measure. Okay, let's translate. I'm just going to do line AE by the directed line segment from B to C. So I've got to translate line AE, this distance, this direction, from B to C. Use patty paper. C, B. You gotta go that way. So every single point on this line has to go this distance and direction. Let's start with A. If A has to go that distance and direction, A prime, I like to put a little indentation, will be here. Every single line, every single point goes this distance and direction. What's going to happen is you're going to draw a line that's parallel to AE, because a translated line will be parallel to its image. I should flip these. I should say a line translated will be parallel to its image. So remember, pre-image is the first thing, image is the second. So a line, the pre-image, that's translated, will be parallel to its image. So, what is true about lines AE and A prime, E prime? AE is parallel to A prime, E prime, because lines translated are taken to parallel lines. You could also say every point on the pre-image is translated the same distance and direction. Take turns with your partner to identify congruent angles. Well, the congruent angles include corresponding angles, like these two, alternate interior angles, like these two, and alternate exterior angles, like these two. So the congruent angles, the pairs of congruent angles will include corresponding angles, alternate interior, and alternate exterior angles. So you got to find them on this. Let's just go ahead and label corresponding angles 1. Angle DBE is corresponding to angle BCE prime. Those are two corresponding angles. This and this are corresponding. This and this are corresponding. This one and this one are corresponding angles. I'll give you one example. There's a ton of them. Alternate interior. We're going to call these 2. Alternate interior. Alternate sides of the transversal inside the parallel lines. Alternate interior. That's a good example. Last but not least, alternate exterior. ABD, angle ABD will be the same as C prime, C, E prime. Alternate sides of the transversal on the outsides of the parallel lines. Here are intersecting lines AE and CD. Rotate line AE by 180 degrees around point C. Okay. $180. There's A prime, E prime, B prime, okay. What is true about lines AB? This is line AB, extends in both directions forever. And A prime, B prime. These are parallel. We gotta find congruent angles. Angle A, B, C, right here, is congruent to angle A prime, B prime, C. So, angle A, B, C is congruent to angle A prime, B prime, C prime. C prime will just stay there because we use center C. Explain. Alternate interior angles are congruent. How about angle DBE? There's a 180. So angle DBE DBE. If we rotate center C 180 degrees, angle DBE falls on D prime, B prime, E prime. So angle DBE congruent to angle D prime, B prime, E prime. Those are alternate exterior angles. Last but not least, CBE, right here. Let's see what happens. Rotate it 180. Becomes C prime, B prime, E prime. Those are alternate interior angles. We showed that these are all congruent through what? A rotation 180 degrees, center C. A rotation is a rigid transformation. Rigid transformation includes translations, rotations, reflections. Rigid transformations preserve shape and size, and therefore those angles are all congruent. do lesson 20 cooldown, then I can actually have some free time where I don't have to worry about one mic, one voice. Attention period 6. In each question, lines AI and GJ are parallel. You can do 2 arrows, 1 arrow, 3 arrows, whatever, as long as you have them the same. That shows these are parallel. Intersected by transversal line FE. Transversal. Use a transformation that takes angle EBI, this angle, to angle BCJ. It's the easy one. EBI. To BCJ. Well, that's easy. What if we just move it, aka translate it like that? So the transformation is a translation via directed line segment BC. Easy peasy. Angle ABC and BCJ are alternate interior angles. Alternate interior angles are congruent. That means there is a transformation. Transformations are considered translations, rotations, and or reflections. Those are the 3 transformations. How do we take angle ABC to angle BCJ to prove they are congruent? Well, what I would do if I were you is measure BC. BC is 3, 1, 2, 1, 2, 3. 3.3 centimeters. Or, in other words, 1, 2, 3, 4, 5. 1 5/16 of an inch. Neither of those numbers is that great to work with. So I'm going to go 3.3. The midpoint of 3.3 is going to be 1.5 plus 1.5. It's going to be right there. Let's call this M for midpoint. So, watch this. M, A, B, C. We're trying to get to B, C, J. You just rotate 180 degrees. There you go. 180-degree rotation around the midpoint of BC. Or you could do this. A, B, C. You could also rotate 180. Just gonna take us to its vertical angle. Rotate 180, and you're here. Translate. Directed line segment, BC. So, it's two options. Option 1. Rotation 180 degrees. Center M. Or option 2. Rotate 180 degrees. Center B. And translate by directed line segment. BC. Those are your two options. Not too thrilled with how my last class went today. I'll be honest. There's too many one mic, one voice. Norm breaking. On Mondays, we only have 5-minute passing periods. There's not enough time to assign seats. So unfortunately on Mondays, I have to trust when people sit next to each other, when people choose their seats. Because I don't have enough time to assign seats. You know I assign seats every day differently, so you work with new people every time. I'm a little stressed right now because I trusted that people, when they chose their seats, would still behave. By following the norms. It didn't happen today. It was a constant one mic, one voice reminders. When you break the norms, it stresses your teachers out. And I just wanted to remind you that if you can't handle your own business, then someone's going to have to handle it for you. So please, follow the norms, whether or not you're seated next to your friends or people you don't know.